Hi everyone, so today we're going to be talking about systems of equations as they relate to distance equals rate times time problems. So you should feel comfortable with the formula D equals R times T. So distance equals the rate or the speed of something times the time that's traveled. Now we're going to look at specifically those examples with currents or winds. So it's important to recognize what upstream and downstream mean. So if I'm going upstream, I'm traveling against the current, okay? So it's going to be harder. So we're going to be subtracting the current, okay? If I'm going downstream, I'm going with the current. So it's going to make me go faster, so I have to add the current. Same thing with tailwind and headwind. Tailwind, I'm going with the wind. And a headwind, I'm going against the wind. Okay, so a couple other things that are important are the vocabulary that we're going to be using or see in these different questions. Airspeed, that's R. That's the speed of an aircraft or a boat in still air or still water. The wind speed, or the speed of the current, is going to either be W or C. And then the ground speed is actually the airspeed plus the wind speed or minus the wind speed. And that's when we're talking about with the tailwind or with the headwind. And again, it could be upstream or downstream. So here's an example. And a motorboat took 3 hours to make a downstream trip with a current of 6 kilometers an hour. The return trip against the same current took 5 hours. Find the speed of the boat in still water. So the speed of the boat in still water or still air is R, okay? So typically what I like to do is I like to make a distance equals rate times time chart. And I think I gave you space for that in the notes. All right, so we have D equals R times T. Okay, so then we also have the downstream, so I label the side, and we have the upstream, okay? All right, so remember upstream is making it harder, so it's going to be going slower. All right, so motorboat took 3 hours downstream with the current, okay? And we're trying to find R. So R is the speed of the boat, in still water. And our current is 6 kilometers an hour. And our time we have for there's 3 and back is 5. All right, and D is unknown to us. Okay, so let's call this maybe D1 and D2 if you want to think about it. All right, but we do know that if I go up and back, the distances are going to be equal to each other. All right, so let's think about this R. So we've got to take the speed of the boat, and we either have to go with the current or against the current. Okay, so upstream we said was harder, so that would be R minus C. So R minus 6, and going downstream would be with the current, so that would be R plus 6. All right, so now I have, because we're talking about a system of equations, I have 2 equations with 2 variables. So I'm going to write them. So we have D equals 3R plus 18. So I multiplied by 3. Second equation, D equals 5R minus 30. Okay, well, the distances are equals, and this is a really nice place to use substitution. So 5R minus 30 equals 3R plus 18. All right, and we're going to solve for R, and that's going to give me the speed of the boat in still water. All right, so I'm going to subtract 3R. I'm going to add 30. So I get 2R equals 48. And so R equals 24. And then I always want to answer the question being asked. So what's the speed of the boat in still water? It's 24 kilometers an hour. All right. Hopefully that was helpful. You're going to try the problems now, okay? Have a great day.